Hi everyone, thanks for tuning in. I'm back with another devlog about my zombie-themed tactical third-person shooter. Today, I'd like to go into much more technical detail than in my first video. Speaking of my first video, thank you so much. We actually hit 4 digits. I really didn't expect that many views. Make sure to check out the introduction of this project if you haven't already. Let's get started. The first thing I did was creating the character models for the squad. Synty's military pack has great modular soldiers which really fit perfectly for my use case. There are some base models and you could equip them with all kind of gear by adding game objects to the bones of the skinned mesh. So I added all kinds of pouches, armor plates and other tactical accessories. I made sure to give all of them some kind of facial isolation, since this is a special operations unit which should also be able to withstand any kind of breathing hazard. I also tried to give all of them a different look to underline their unique special skills. Their appearances might change later, but I'm quite happy with the result for now. The next thing I'd like to talk about is the player controller, or rather, how I make my character move and let him interact with the world he persists in. If you ever tried to make a player controller on your own, you likely did realize that it's a pain. Things like gravity, grounded status, slope handling, it's pretty daunting and time consuming to get it right. Luckily, I picked up a very good asset a while ago called Kinematic Character Controller. It's a pretty well thought out and robust character controller, and it even integrates super easily. You just have to implement an interface, inject your own logic into the inherited callback methods, and pass rotation and velocity to the system. That's it. I especially like the slope handling with this one. You're basically stuck to the ground and have to call a distinct method to unstuck yourself and perform a jump, for example. Very cool and makes moving vertically so easy. First, I generate a vector that points in the desired direction the player wants to move based on buttons pressed and the camera position. Speaking of buttons, I am using Unity's input system and I'm quite happy for now. The event-based input handling really works like a charm. Next, I change the character controller's velocity based on this movement vector and apply some drag to stop the player from moving if nothing is pressed. I outsourced all of the input related code into a dedicated class that can be accessed from anywhere. Alright, so far so good. The character is moving, but now animations. I'm using a blend tree to smoothly blend between different walking animations based on the velocity vector. I can really recommend the asset Animancer, which makes animating things so easy. It helps by getting rid of the Unity animator hell and lets you control your animations 100% through code. Very nice. As for the camera, I created a simple camera setup by rotating the root of the camera based on the mouse input. I am also using virtual cameras from Cinemachine to switch between the standard camera and aim camera later on. You really just have to disable one camera and it automatically moves to the next one. Very handy. Another feature I added was foot IK. I hate the look of animated feet that don't touch the ground properly. Luckily, smart people came up with an algorithmic solution for this problem: inverse kinematics. By now, I'm sure everybody has an idea about what it does. You basically feed the algorithm a target position and it automatically adjusts all limbs between the start and the endpoint to fit the target. Much like real arms would behave if you were to reach for a glass of water, for example. However, IK is a big topic to wrap your head around, which is why I used another asset, Final IK. Final IK is the godfather of inverse kinematics in Unity and really the only IK asset you will ever need. Final IK comes with a full body biped IK, which basically lets you move a whole rig character with IK targets. It also comes with a distinct component called foot IK, which instantly yields great results. It basically pulls down the character until both feet touch the ground and also places them naturally to fit the incline. It was really as simple as adding the component and being happy because you didn't have to deal with the headache yourself. That's what a good asset does, saving time and making happy. The character moving, let's now jump to the custom aiming system I implemented. Firstly, the whole aiming is procedural, which means the arms are driven, again, by IK. The rotation related logic is executed in late update. If you didn't know, there's an update lifecycle unity which basically tells you which things get executed in which order. And, you guessed it, late update is being called at the very end before the frame gets rendered. This means you can override animations in this part of the update loop. And that's exactly what I did for the aiming. First, I check if the right mouse button is held down. If so, I level a float value to 1. 0 means the player isn't aiming, and 1 means he's fully in the aiming stance. This is very useful, since I now have a smooth representation of the current aiming progress of the player, which I can use in other scripts. Next, I store the angular offset of the player mouse input, and then make the spine of the character rotate to that angle to make the player actually aiming at something. To make you better understand what happens with the guns, I'd like to introduce the gun space. It's basically just a game object that sits on the spine and has every single gun in it. Now, every gun has its own designated space within this gun space. To make the gun move and the player aim, the gun's position and rotation gets slurped from one point to another within said gun space. To clarify, there is a position which is the rest position of the gun, for example during walking, and an aim position which represents the gun's position when aiming. Now, when the player starts aiming and the gun moves into the aiming stance, the arms automatically follow the gun because they are attached to it using inverse kinematics. I choose the procedural approach because I'm more of a programmer rather than an animator, and also because inverse kinematics makes it very easy to adjust animations and also overall integrates very easily with code compared to fixed animations. The big cool advantage of the gun space is that you can rotate it as a whole and move every gun in it. This is useful to create a bit more depth in the aiming. Rotating just the spine feels pretty flat, but making the arms move independently of the spine feels much better. Speaking of game feel, you might have noticed the inertia of the aiming. I used springs to achieve this effect. Springs are exactly what you think they are. A spring has a target value which it seeks actively and a current value. Of course, you're able to tweak the behavior of the spring with certain parameters. You can really add so much more life to your game with springs, you should definitely use them. Make sure to check out this cool video to get a better understanding of it. I also added a procedural shoulder rotation in late update to better shape the final aiming stance. Humans tend to hold different guns very differently, so I had to implement an option to adjust the way the character is holding the gun. As for the laser, it really isn't witchcraft. The laser consists of a line renderer. I then raycast via script and set the positions of the line renderer dynamically, based on whether the player is aiming and what he's looking at. Next, I added a custom laser shader using the all-in-one VFX shader asset. You can build almost any kind of shader out of that asset without having to write a single line of shader code. Very helpful. And that's it! Now we got ourselves a fancy laser, which also has a small indicator on it if something is shootable. I plan to add alternate aiming options to the game so you can use a minimalistic laser or a UI based crosshair. The color will be adjustable as well. Alright! With the aiming system in place, I obviously also needed a gun system to make full use of the aiming. With me being a big shooter fan myself, creating a custom gun script was one of the first things I've ever done in Unity. so I already ran into typical gun problems in the past, which made the creation of a gun controller very easy now. The gun controller takes care of all the things a gun can do: shoot, reload, recoil. All actual gun properties such as RPM, damage, magazine capacity are stored in a scriptable object. Everything technical is located in the gun script directly. Fire modes and shotguns are also supported. I wanted to create a complex hierarchy of inheritance to create different types of weapons at first, but I went with the universal approach. I don't need that complexity since all of my guns would behave more or less the same. I plan to implement some special kind of weapons later on, but these will need their own logic regardless, so I'm keeping it universal for now. I added a couple of VFX and animations to the gun, such as muzzle flash, muzzle light, muzzle smoke, muzzle sparks, bullet eject, and a simple slide animation to really sell the effect, and I really like the outcome. As for the recoil, I used swings again and always offset the swing's current value whenever the gun was fired, and apply rotation in late update based on this swing, which results in a nice procedural recoil. I also added camera recoil. This is a mandatory feature since a gun without any haptic recoil feels bad. I plan to add recoil animations for the guns later on, but I also don't want to overdo it. It's fine for now. Shooting feels not bad actually. With the shooting working, I now had an extreme bloodthirst to kill things. So I started to work out the enemies/zombies. I had a plan for the enemies being an active ragdoll, but it turned out pretty quick that things didn't work out as imagined. I took a messy shortcut and briefly threw something quick and dirty together to see how it feels, which I really didn't want to do, but I really had to kill something. It felt great, but the AI code was a mess. As you can see, I also plan to implement dismemberment, but it's very cheap and simple at the moment. I definitely have to take another go at this in the future, but I stopped here for now since the whole enemy AI stuff was pretty draining. Of course, planning and concepting is a constant process during development. I have a good idea in which direction the story should go by now, and I'm also working on level concepts and designs. There will be a forest section at the beginning of the game, before you enter a big bunker/laboratory which will act as the main location for the game. But before running into any actual level designs, I want to get most of the core implemented at first. What's the use of a fancy level or boss enemy if I can't even walk, shoot or pick up items? Complete nonsense. Also, the worst thing that could happen is to redo levels due to mechanics that were implemented after a level was created. So I might have to adjust or redo a whole level based on a new mechanic, which is unnecessary work I can avoid if I correctly set my priorities. But yeah, things progress at a steady pace and I really dig the progress I made already. The next big tasks would be basic enemies and working AI teammates. But these are very important tasks which I want to get right. I also plan to implement a grid-based inventory later on. Long story short, my Trello board is stuffed and there's enough to do. I plan to release a small demo level for you to play and try out the controls in the future. The earlier I can gather feedback, the better. Alrighty, I think this wraps up my second devlog. Thank you for being a part of my journey. Let me know what you think and feel free to write any ideas, questions or feedback in the comments. Make sure to subscribe to my channel and hit the like button if you enjoyed watching. You can also take a look at my socials and hit the bell to stay updated about this project. As always, have a nice day and please don't spill your beer.